This is not an intro problem for sequences, but it's also not hard once you see the trick. The trick is that instead of starting at the first term, which is usual, we're going to start at the kth term as the starting point. Okay, so it's just going to be a little different. We're going to work through it as if that line that I just highlighted is not even there, and then we'll make one change, and that's it. That's the answer. So this is an arithmetic sequence, right? It tells you that. Not in words in the instructions right here. That doesn't say anything about arithmetic, but if you look at the sequence itself, you can see that as you hop from one number to the next, we're always going up by the same amount. Okay, so that looks arithmetic to me. And if you're not sure what the arithmetic difference is, the common difference, you simply take the second term minus the first term, which in this case is negative 17 minus negative 12. So that means our common difference is negative 5. It's going down by 5 every time. Well, that's great. Now we just need to write our explicit formula. AN equals A1 plus D times N minus 1. And we plug in what we know. Well, we know that A1 is negative 12. We know that D is negative 5. And then we have our N minus 1. And normally this would be enough. This is an arithmetic sequence with a common difference of negative 5, and it starts at negative 12. However, we still have that little thing here which says, no, I don't want you to start at negative 12. I want you to start at the third term. So here's the trick, and it's surprisingly easy. We just cross out A1 and replace it with what we really want to start at, which is A3. So if we do that, we get the following. AN equals, what's the third term? Well, it's right up here, negative 22. So we say negative 22 plus negative 5 times n minus 1. Now, you could leave it that way, I suppose, but most people would feel a little icky and they want to simplify it. So let's just do that. It won't take much time. This is negative 22 minus 5n plus 5 once I do that distribution. And what I get if I rearrange is negative 5n minus 17. That is my explicit formula for this arithmetic sequence starting at the third term. Okay, coming over here. First thing I'm going to do, because I suspect this is not arithmetic anymore, and you can see there's nothing you can go, there's no common difference where you can go from 7/5 to 6/5. You might think that's negative 1/5, but it sure doesn't work on the next one, right? So how do we do this? We have to check for geometric patterns, and that is simply A2 divided by A1, okay? Which in this case is going to be 6/5 divided by 7/5. And if you do a little keep flip change action, I'm going to skip that, but you get R equals 6/7. And normally we could write this really fast now using the explicit formula for a geometric sequence, which is just A1 times R to the n minus 1, okay? Well, put in A1, that's 7/5. Put in R, that's 6/7. Put in the n minus 1, and normally we would be done, except there's that what if, that by the way thing where it says, oh, by the way, we want you to start at the kth term. This is the fourth term. So that's not going to cut it. We have to not use A1. We have to use A4 instead. But that's the only change that has to happen. So this one just becomes AN equals, we'll find the fourth term. Where's that? 1, 2, 3, 4. Right there. It's kind of gross. 216 divided by 245. And that's going to be times the common ratio of 6/7 times n minus 1. Okay? And that one doesn't even need much simplification. It's pretty handy. So that's how you do this. It's honestly a lot easier than it looks because that counting thing can be a little distracting, but you just swap in the third term or the fourth term or whatever it is in place of the first term, and that's your new starting point.